times that he does your lessons. Starring his students, who may or may not be watching these videos in their pajamas. And our returning champion, Kaya, a well-known mathematician in the cat community.
Help out. There we go. Let's get the pencil.
Get working, Lydia.
Okay, keep working, Kaya. Should we multiply by x plus 3? Yes, we should. Everyone loves math. It is wonderful, isn't it? Oh, yes, it is, it is, it is. It's very good. Very good. Math makes us smarter. Okay. X minus 4. Hey, helping out. Good job. Plus 5x plus 15. Over 2 times x minus 3.
And it's good to have another week of e-learning, and I even broke out a tie for this Monday morning. It's been a long time since I've worn a tie. You know, 2 silkworms got in a fight. You know what happened? It ended in a tie. And so, welcome back. And here we are, e-learning for Monday, April 20th. Make sure you fill in the attendance form. Now, I updated the attendance form for this week, and some of you are trying to take attendance for last week, and you're like, oh, it changed. What about a concept of attending school and taking attendance? Today is Monday. Take attendance on Monday. Sounds like a plan. Make sure you get that done. And then Wednesday, and then Friday, and so do that. And so today, in geometry, we're going to talk about dilations. But before we get to that, the notes are here linked. The assignment is 116, page 596, 1 to 16, and problem 27. But we have new warm-ups for this week. And so there's just 3. Not any more than that. You can get them all done today. You can work on them all week. It doesn't matter. Just try to get those done. And if you hear that sound in the background, that means some of you are emailing me, and I am not getting back to you till we get the video made. And so this week for logic problems, we actually have a new online math contest. This is new. It's the same type of questions that you got last week for your logic. And you have to have this done by 6 p.m. on Thursday. And we paid money for you to do this. And so you need to do it. And so I'll be sending you an email that contains your specific username and password. But in the meantime, while you're waiting, you can click on this link right here, which is a practice test. And on that practice test, it's a 2nd grade test. But just to show you what it will be like, there's little boxes where you type in the answers, 4,033, and you're not supposed to use a calculator on this. This one, I'll just skip down. That one's 64. I'm not really reading them. I might miss them. And you go through, maybe this one's 19. And you go through. Then when you're all done, you will have 45 minutes, but they'll give you an extra 5 minutes, and I think they give you a 5-minute warning and things. And you can just, the purpose of this practice test is not to get them right or wrong. It's just for you to look at it so you know what it's going to be like. And then when you're all done, you hit submit. Now in the practice test, it tells me right here, my score is 10, and the correct answers are in red. And if I would wait long enough, it would tell me my time's going to be up. But on the real test, you are just going to click submit, and it will not tell you the answers. And so I will know that you took it, and in a couple weeks, we'll get all the results. And on the contest, the top 5 scores will make up our school score. There's a 6th grade contest, a 7th grade contest, and 8th grade contest. So you're not competing against the other grade levels. It's just 8th graders, 7th graders, and 6th graders. And so you'll be taking the 8th grade contest. And you have to have that done before Thursday night. And so sometimes set aside 50 minutes after I get you your username and passwords. Set aside 50 minutes after you kind of look at this practice test, and then take it, and then submit it, and you'll get extra credit. And then we'll see how well you do in a few weeks. And so make sure you do that. Okay? And so we got warm-ups, the logic problems. You don't have till Friday or Saturday or Sunday. You have till Thursday. And we actually have another online Math Madness one that we sent all of you an email, and that's occurring at Friday at 11 a.m. And so have that. And so I have a lot of information here about your logic problems, and your warm-ups and the assignments. And so we have the notes here. And so we're going to go ahead and start talking about dilations. Well, that's the homework page. And so we've talked about rotations, we've talked about reflections, we've talked about translations, we've talked about glide reflections. Those are all the 4 basic isometries. They don't change the shape or size of an object. If you slide it, it's still the same size. If you turn it, it's still the same size. If you slide it and flip it, it's still the same size. But if you reflect it, it's still the same size. But when we dilate, usually the only time we use the word dilation is these things. When your pupils dilate, they get bigger, they get smaller, but they're still the same shape because all circles are similar to themselves. And so we're going to talk about dilations today. And so we're going to set this up, and I want to make sure it's big enough so we can see it all without me getting in the way. And so we'll start right here. And so just like when we did rotations, I had a capital R right here. D means dilation. And when you dilate something, you dilate it around a point. Well, O means the origin, so we're right here. That's where we're going to dilate. We're going to either make it bigger or we're going to make it smaller. We're going to zoom in or we're going to zoom out. And so that's a dilation. It will be a similar shape. And so, and then this is how big we're making it or how small we're making it. And so a dilation by -2. If this number is greater than 1, it's going to get bigger. But if it's also less than -1, it's going to get bigger. The negative you'll see here in a second. If the number here is between 0 and 1, less than 1, but greater than 0, it's going to get smaller. And the same thing as if it were negative between 0 and 1. And so we'll talk about that also in a second. And so first thing we want to do is plot this. So we have point A, 0, -2. Hopefully I don't goof this up. There's 0, -2. Point B, right 1 up 2. Here's point B. And point C is 2, 1. And so we have 0, -2, 1, 2, 2, 1. And we're going to get our straight edge out, and we're going to connect all these. And so make sure we're in the right color. We're going to go here, here, and here. And so there is our point A, point B, and point C. Now, when you dilate something, it's really pretty simple. You just take, I wrote up here, I need this space. If you take a point, XY, and you want to dilate it by -2, if it's dilating it around the origin, the answer is as simple as just taking the x-coordinate times -2 and taking the y-coordinate times -2. And so if I have the point 0, -2, just multiply both those numbers by -2, and 0 times -2 is -2, and -2 times -2 is 4. 1 times -2 is -2, 2 times -2 is -4. And then for point C, if we're going to multiply each of those by -2, what would we get, Carissa? -4, -2. Excellent job. So how are we going to plot the point 0, 4? What's that going to be, Isaiah? Is it over here or is it up here? It's over here? No, no, no. It's going to be up on the y-axis. Right here. Good job, Isaiah. So that's going to be 0, 4. And then B is going to be -2, -4. That's going to be down here. And then C is going to be -4, -2. And so we're going to get all this set up for you and change to the color blue. Skies are blue somewhere over the rainbow. Do, 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 do. So there we go. Now let's label those points. So A is now 0, 4. B became -2, -4. And C became -4, -2. So this is C prime, B prime, and A prime. Now there's a lot of things you notice. First of all, when you're multiplying by 2 or -2, this side became twice as long. And this side became twice as long. And this side became twice as long. But then there's something else. That when you connect A to A prime and B to B prime and C to C prime, this is going to help on one of your warm-up questions, finding the center of the dilation. If you just connect C to C prime and connect B to B prime and connect to A prime, where do all these lines cross, segments cross? They all cross at the center of the dilation. And so that should be an easy 4 questions. So hopefully you don't go, the warm-ups took me hours. It should go 4 questions. Just where do those lines cross? And that's the center of your dilation. But then there's something really cool about this. That if that's the center of your dilation, from to the center of the dilation, and then from the center of the dilation to B prime, notice how that's twice as far. And so when you go here from C to the center of the dilation, and then you go from the center of the dilation to C prime, that's also twice as far. And look, this was 2, and then this is 4. And so you see that not only are the sides of the dilation twice as long, the distance to the center of the dilation is twice as long. And notice one other thing. When your dilation is a -2, it not only makes it 2 times bigger, the negative actually gives it a half turn from yesterday. And so if we have this, or from Friday, yesterday to the teacher, the half turn dilating by a negative not only gives you a dilation, it also does the half turn at the same time, which is kind of cool. And so we said that yesterday, if you had the ordered pair XY and you had a half turn, how could we write those coordinates? And so it involved taking the negative. And so that is a half turn, and it is 2 times bigger. And so make sure you know that. Okay, we had some technical difficulties, so if you didn't notice, I kind of inserted. I actually finished teaching this entire lesson, and it only saved up to a point a minute ago. And so here we are retaping it. So we tried to pick up where we left off and edit it. And I never knew being a math teacher meant I have to be a video editor. And so we're going to take this away, and I put that back on from the first video. And here we are back to the notes. And so right here, if we fill these in, a dilation is not an isometry. Isometries mean they're congruent. They preserve distances. And a dilation gets bigger and smaller. And so only would it be congruent if you multiplied by 1. And so a dilation always maps to a similar shape. Therefore, in similar shape, corresponding angles are congruent. So the angles, the corresponding angles, stay congruent. And so you want to make sure. I remember playing Mind Trap, and it says, under a magnifying glass that doubles everything, you have a 45-degree angle. And when it doubles it, whoa, it's still 45. It doesn't all of a sudden open up and become a 90. Angles stay the same. And so the angles stay the same. A dilation, excuse me, can be an expansion if we're dilating by a number that's greater than 1 or a number that's less than -1. Like 2 means you're going to double it, and 3 means you're going to triple it, and 2.5 means you're going to take 2.5 times it. Or it can be a contraction, and that means your K is between 0 and 1, or if you're going to do a half turn, between 0 and -1. And so a contraction, and if you're dilating by 1/3, it's going to take 1/3 or come in 1/3, and so towards the center. And so that pretty much will get you most of your homework. And so if we look at this on your homework, the very first parts, it's find the coordinates of A, B, and C given the dilation. And if you're dilating O means you're dilating around the origin, and you're going to double everything. So what you're going to do on your homework for these first problems is you're going to write point A, which used to be 6, 0, but you're going to double them, so it's going to be 12, 0. You don't have to graph it. Point B, which over here was 4, 2, is now going to be 8, 4. And point C, which is going to be 2, negative 2, C prime is 4, negative 4. And so this would be A prime, B prime, C prime when you dilate it. You can do the same thing here. We're going to dilate around the origin, and we're getting 3 times bigger. So you're just going to multiply this by 3, and multiply this by 3, and multiply this by 3. Not too tough. Until you get to 7 and 8. We're going to dilate it around point A. Well, here's point A. We're not going from point O, from the origin. See, when you dilate around the origin, like problem 3, and you take 4, 2, and half of that's 2, 1, you're coming in half the distance. 6, 0 becomes 3, 0. You're half the distance in from the center. And if you're at 2, negative 2, you'd be at 1, negative 1. And so here's your, this is pretty bad. That was really bad. I'll draw it again. And so here's your new image. And here was your original image, the pre-image. Notice how it's half as big. It's coming in closer towards the origin. But how do we do that when we're going around point A and point A? And those are the tough ones, 7 and 8, and the last problem on your homework, because you got to do 1 to 16 and then problem 27. And those don't have the center as the origin. So let's go back to your notes. You probably don't like it that I skipped around. But if we go back to the notes, there is a formula when the center is not at the origin, where the center of dilation is point O, which normally means the origin, and we're multiplying by scale factor K, but the center is at AB. And here's a formula. It's like, what's that mean? I don't know what that means. And so we're going to tell you what it means by doing an example. And so we're going to move me up here somewhere and take the sound off me. And hopefully, I noticed tonight we're having trouble videoing. My mouth doesn't line up with the words, and so I have no idea. Just bear with, and if it bothers you, don't watch me. Just listen and listen to the notes, okay? So what we're going to do is we're going to take these 3 points, negative 4, 0, negative 3, and negative 2, 0. We're going to plot them. So A is negative 4, and hopefully I don't plot these wrong. B is 0, negative 3, and C is negative 2, 0. And the center, the sun, you know, like in a hologram, you have the light, and it turns on, and then out from it appears Princess Leia on the Millennium Falcon. Obi-Wan, you are our only hope. You are our only hope. I don't think I quoted it exactly correct. But then they turn it off and comes back from the light. So here we are at negative 5, negative 9. Is that negative 9? No, that's negative 8. So here we are at the sun. And that's the center of your dilation. Well, from that sun, you got sunshine. It's a sunshine day. Whoa, that's not sunshine. That's red. That'd be sunburn. And so we're going to shoot a ray through the sunshine. Whoa. And each corner of A, B, and C. If I can get this here. It's a sunshine day. Everybody's singing. Now, look at this. We have our original triangle. A, B, C. And if we're going to go around the center dilation here, if we're going to multiply these by 2, you can't just multiply these by 2. That only works if you're at 0, 0. If you plotted -8, -8, you'd be down here. And you're not dilating from the center. And so what you do is, you could just draw it out and think about it. Well, here I am. Hello. We go one distance. That's like a slope of 5. Up 5 over 1. So we'll make a new triangle here. And we'll go up 5 over 1 again. And that'd be the corner of the next one. This one would be up 9 over 3. So if we go up 9 over 3 again, that point going out on this ray, if it's a dilation of 2, it just means you're going another set because you're twice as far, not from the old point, you're twice as far from the center of the dilation. And then over here, this one is like up 6 over 5. So if we go up 6 over 5 again, that would mean that that point is right here. And then we would graph this. And this is kind of difficult, especially through distance learning. And you can't stop me and say, Mr. Nyson, stop. I have a question. Stop, stop. You messed up. Hopefully not. But you know it's going to happen, and it'll happen again. And so here is my two triangles, and one's dilated, and they're coming out from the center. Look and see if we can find these corners of the new dilation, and then see if we can figure it out without drawing a picture. So here is A, and it goes to A prime. Well, that would be, A prime would be -3, 1. And obviously, you can't just take -4, -4, multiply it by 2, and get this. That doesn't work. B prime, B is here, 0, 3. B prime's over here at, or that was 0, -3. And B prime is 5, 3. Well, obviously, you don't just take 0, -3 times 2. And C prime, which was -2, 0, now comes all the way up here to 1, 9. Well, you're not going to get that either by multiplying by -2. So how are you going to get it? Well, the thing is, you got to like restructure the problem. If your center of dilation is -5, -9, you want to move that so that goes up to 0, 0. You want to pretend that this is the new axes. And so like pretend that this is your x-axis and this is your y-axis. When we shift it back, it'll look like it's online. There it is. And so we want really for this center dilation, which was -5, -9, to become the new 0, 0. And the way you do that is add 5 to all your x values and add 9 to all your y values. And if you do that, let's look and see what we get. This point, if we add 5 and add 9, would become 1, 5. Well, look, that's what this point is. It's 1, 5. If this were 0, 0. And then we add 5 and add 9 to these two, and this would become 5, 6. Well, look, B is at 5, 6. Whoa! And then this would become, if we add 5, that'd be a 3, and add 9, that'd be a 9. And let's look where point C is. This is point C. This is point C prime. And so sure enough, that's at 3, 9. Then if that's at 3, 9, you would double it. 1 doubled, 5 doubled is 5, 10. But see, that's not -3, 1. We're not done yet. Then you take the 5, 6 and double it. See, here's 5, 6. You double it, you get B prime, and that would be 10, 12. And if this were your x and y axis, sure enough, that's at 10, 12. And then 3, 9 doubled would be 6, 18. And if you were counting from 0, 0, this would be 6, 18, way up here. But we're not counting from 0, 0. We're counting from here. Well, then how do you go back? Well, instead of adding 5 and adding 9 to go back, we're going to subtract 5 and subtract 9. Look. what is, oh, this is wrong. This is not a 5. That's supposed to be a 2. It's like that point should have been 210 right there. So A right here, A prime would be 210. So you're doubling it. 1 doubled is 2. Oops. Now how do you go backwards? Subtract 5. What's 2 minus 5? Negative 3. Subtract 9. What's 10 minus 1? 9. What's 10 minus 5? 5. What's 12 minus 9? 3. What's 6 minus 5? That's a 6. 1. What's 18 minus 9? 9. And so what you do is you do the original problem. You can't really see me pointing because I'm over here. But you do the problem, the x and y axis. Make 0, 0 through the center of the dilation with those red x and y axis. Then do the problem. And then that would be from there. And then you can just convert it back. When in doubt, draw it out. Okay? So there's only a couple problems on your homework tonight that 0, 0 is not the center of the dilation. And 2 of them are 7 and 8. So you could do our little trick and say, for problem 7, make this the x-axis, make this the y-axis, and then B and C would no longer be 4, 2, but this would be negative 2, 2. That would be the location of B. And C would be negative 4, negative 2. And then you would multiply those points by negative a half. See, this point here now is negative 3. No, that's wrong. Negative 2. I hate it when this shifts. See? Here, look. We'll shift it back. And so, oh, that's because I drew the line through the wrong A. And then it shifts it. No wonder. So there we go. See, that's your new x and y axis. And so if you're going negative 1/2, this point is really negative 2, 2. And when you multiply it by negative 1/2, that would be 1, negative 1. And so it would be right there. But see, that's not really there. That's really 7, negative 1. But see, when we convert it, and then C, which is in the new, if we shifted it, it would be negative 4, negative 2. And if we take those each by half, it'd be 2, 1. But is that really 2, 1? No. Those 2 points are not really 2, 1 because that's not really the center of the dilation. But that would be a way to draw it out. And see, here is your negative 1/2, half turn. Your original ABC was there. And the new one is right here. And A doesn't move. And A is not going to move here. It's just B and C are going to move. So you can draw it out or think about what we said and try to get that. 9 through 14, those are pretty self-explanatory. Remember, invariant means does not change. Parallelism, those are the rays coming out. Okay? And you can look at that. And then the last one was the problem 27, and that's with the center dilation. That one's odd, but you should try it. Email me any questions you might have. And just remember, these videos in pre-algebra, I got 23 likes last Friday. In algebra, I got 14 likes. In geometry, I only got 3 likes. That's why I started wearing a tie. Maybe you'd like it more. And so, if you got any questions, let me know. You guys are all doing a great job. Keep up the good work. And so, I'm going to get username and password for your logic problems, which will have to be done before Thursday night. But time's fun while you're having flies. That's what Kermit the Frog always says. So, okay, we'll see all you guys. Let me know if you have any questions. Email.